Good afternoon, guys. As you can see, I'm not with you this afternoon. Unfortunately, over Thanksgiving break here, my grandmother passed away, so we are having her funeral today. I will be back tomorrow. Your grades for your quizzes that you took before break are in progress book. We will go over those tomorrow, and then if anybody would like to retake, you can retake. And we'll go from there. Okay, so today we're going to start chapter 3, and chapter 3 is all about the derivative. This is one of the main topics of calculus. Okay, so limits and derivatives, and finally we'll get to integrals. Those are the three main topics of calculus. So we're on main topic number 2 here. So you can see our objectives. Let's go ahead and get right into it. Okay, so I have definition 3.1 for you. Okay, this is right out of your textbook. Okay, you can see that we use this notation f prime of a right here. That is how we denote that we want to find the derivative of f at a. And you can see that the derivative's definition is a limit. Okay, so this looks very familiar to you. The limit as x approaches a of f of x minus f of a all over x minus a. Now I just want to remind you of a couple things here. Okay, you know that we use the limit to find the slope of the tangent line. You also know that we've used the limit to find the rate of change, or the speed. With that, speed with direction is called velocity. So we have this whole list of things now that we've used to find the limit. We have the slope of the tangent line, we have speed, also called rate of change, or speed with direction called velocity, and now we have the derivative. So all of those things mean pretty much the same thing. Okay, so let's go ahead and try one. Okay, this is my function f of x. You can see it's a quadratic with the power of 2. I want you to find f prime of -1 and f prime of 3. So basically this is 2 problems in one. I want to find the derivative at -1, and I want to find the derivative at 3. So I'm going to use that definition that we just saw back there, definition 3.1. So I'll go ahead and do this first one here. We have the limit as x approaches a. Well, in this case, our a is -1. Okay, of f of x minus f of a. Well, if I take -1 and plug it into my function up there, I get 1.25 all over x minus a. So, I'm sorry there. This definition is nothing different than what you've been doing to find your limits. So this should be pretty familiar to you. So I'll go ahead and work out this problem here. Pause it if you need. Okay, and hopefully you can follow what I'm doing here. So there we are. What am I trying to evaluate this at? At -1. If you put -1 in there, we get our derivative to be -1/2. Now I kind of skipped over something here. Obviously we're doing this limit and we have to manipulate it because we have a domain error right in the beginning. I cannot put in -1 right at the beginning. So of course you know that's when we do our manipulation. Okay? Alright, well let's try the next one. I wanted you to find f prime of 3. Oops, I kind of forgot my prime symbol up here. Sorry about that, guys. That means the derivative. So here we go. The limit as x approaches a of f of x minus f of a. Well, if I go to my function there and I put in a 3, 3 squared is 9. 9 times a fourth is 9 fourths. 9 fourths plus 1 should be 13 fourths. all over x minus a. So that's what my original limit looks like. I'll let you do the work here, okay? And I'll tell you I get my final answer to be 3 over 2. So hopefully you can do your manipulation to get that same result. All right, let's try this one. We've got a rational function up here. I want you to find f prime at 1. So here we go. I have the limit as x approaches a of f of x minus f of a. Well, if I put a 1 in there, I get negative 1. I'm sorry, if I put a 1 in there, I should get 0. Yep, when I add that 1 at the end, I should get 0. So I really don't have to subtract anything off of that. All over x minus a. Well, we're going to have to do some manipulating here. So I think I'm going to multiply top and bottom by x to get rid of that fraction. And now I have this in my numerator. And this in my denominator. Well, I'm going to rearrange that numerator so it's in the proper order for me to do some factoring. And now I'm able to plug in that domain value of 1, and I get a derivative of 5. Again, what does this mean? That means if I graph this function, and I want the slope of the tangent line at 1, I will have a slope of 5, meaning the tangent line is fairly steep at that point. All right, let's see what else I got for you. Let's try a square root function. Okay, so if I want to find the derivative at 4, I'm going to go ahead and just work this out for you. You can pause it, stop it. Hopefully you'll see what I'm doing, and we'll be a-okay here. And now I'm ready to go ahead and plug in my domain value. And I get that. So at this function, the slope of the tangent line, the value of 4 is negative 1/16. So that means we have a really relatively flat tangent line there. Okay, so this has all been using definition 3.1. F of x minus f of a all over x minus a. There's a couple other forms of this definition that I want to make you aware of. Okay, this is definition 6 in your book. Now when you do your homework, sometimes they will refer to definition 6. So this is the definition we're talking about here. Notice we have different variables that we're looking at here. I have the derivative at x is the limit as t approaches x of f of t minus f of x all over t minus x. Typically, folks, we use this when there is no value given, okay? That means if they're just asking you to find the general form of the derivative, not any specific domain value, okay? I want to stress that a lot. Now, this definition, as well as that last definition, are okay to put on your yellow sheet if you'd like, okay? So there's different times when this one's better versus the other one. So let's get some experience here and do some practice with this definition. So, okay, here we go. I'm asking you to find the derivative of this function. But I'm not telling you what value that we're going to be evaluating at. So this is where you'd use that definition 6. So here we go. If I want to find the derivative, I'm going to have the limit as t approaches x of f of t minus f of x. Notice I changed that to a plus because it'd be minus and minus all over t minus x. And we'll just manipulate this like we always do so that I can take t as it approaches x. Right now, I can't have t approach x because I would get a 0 at the bottom. Okay, so this is what it'll look like. Okay, so there we go. We manipulated it to get rid of our domain error because I want t to approach x. So that means this t right here is supposed to be approaching x. So if it's approaching x, well, then it's becoming x. And now we can simplify this to be negative 10x. Again, this is just the general form of the derivative. It is not being evaluated at a specific domain. Let's try a cubic. Again, notice no domain given. Remember, t is approaching x, so I cannot do that as is, because if t approaches x, I get x minus x in the bottom, and that will be 0. And of course, we know we can't have 0 in the denominator. All right, so we're in business now. If t is approaching x, then we have this. Well, that x in the middle is just x squared. So now I have 3x squared, and that would be my derivative. All right, let's make it a little bit harder here. Let's look at this one. So I'll apply my definition. We're subtracting this entire function in terms of x. So make sure you put parentheses around it. And that's what my definition looks like. So let's distribute that negative symbol. And you'll notice the radical 7s will disappear. And now I'm left with this. So let's do some manipulating. Completely legal, and it's going to get rid of my fractions within fractions up top there. And now we can let t approach x. And it looks something like that. After simplifying, here is my derivative. Okay, and I think that's my last example for you, looking at that definition. I've got one more definition for us to look at. This one is typically not used very often. Okay, but I want to show it to you just to have you prepared. You never really know. when you might see it. So let's save that homework for a second, and let me give you this definition. So that is what the H definition looks like. So we have a definition that has X's and A's in it. We have a definition that has T's and X's in it. And this is the definition that has X's and H's in it. Again, they're all finding the same thing, okay? But some are more reasonable in different situations than others. So I'm going to go back and I'm going to rework, probably 2 of the examples that we already did using this definition. So let's go back to this problem. Let me find it here. And let's find the derivative. Now, I'm not going to give you any value, okay? So we're just going to use this definition shown up there in blue. So here we go. The limit as h approaches 0 of f of x plus h. So what does x plus h mean? You're going to be putting that in everywhere you see x. So there's f of x plus h minus f of x, which is just my original function, all over h. All right, so let's do some manipulating here. I need to square that quantity up top, and I need to distribute my negative sign. So here's what that'll look like. Now let's distribute that 1/4. Oops. Uh-oh, I missed something right in here. There should be another +1 because of this guy up here. So I missed that when I was doing my my foiling here, taking that to the second power. So let's not forget that when I come down to combine my like terms. Okay, so that is my numerator all over h. So I squared the x plus h, I distributed the negative sign, and I distributed a 1/4, and this is where I'm at now. Now notice I can't plug anything in because h is approaching 0, and that will get me a big fat 0 in the denominator. All right, well, if you look at what we have now, we can do some, oh my gosh, I did it again. Let's go back here, folks. This numerator needs to be relooked at. So if I distribute the 1/4, forgot about my +1, so there's a +1, and now let's drop all the rest of that down. Okay. So here we are. If I start to combine my like terms, this goes and this goes. This goes and this goes. And now all I'm left with in my numerator is that. Well, I got to get rid of the h in the bottom. Well, let's factor out the h. And I have this. And they'll cancel. Remember, h was approaching 0. Well, if h approaches 0, all that I have left is that. Now again, this definition is going to be used if no value is given to you. Okay? So I screwed up a little bit in the middle there, and I might have confused you a little bit. So let's try one more. Let's try and rework this one using this h definition. So if I want to find the derivative, this will be the limit as h approaches 0 of f of x plus h. So everywhere you see an x, you're going to put in an x plus h minus the original f of x. Now again, this is just my numerator. This is all over h. So I'm going to leave out the denominator for a little while I work with this numerator so I can try and get some things straight. So let's distribute the 2. Let's distribute the minus sign. And it looks something like that. Oh, well, there's some things I can cancel out here for me. So now, that's my numerator. Everybody doing okay here, I hope? Remember, this is all over h. So let's get rid of that fraction with a fraction. And let's multiply the top and bottom by x and x plus h. So what does that make my new numerator? Well, the first thing, if I distribute that all the way over here, that's going to be 2h times both of those. Minus, if I multiply this one, the x plus h is going to cancel. So this would just be 3 times x. And then if I multiply this one, the x is going to cancel. So this will be plus 3 times x plus h. And my denominator is now h times x plus h. All right, let's do some combining here. First term up there. I have 2hx times x plus h minus 3x plus 3x plus h. I'm sorry, 3x plus 3h. Again, this is just my numerator for now. All right, let's distribute up front here. And look at what's going to happen. I probably could have done this in the last step, but there we go. And now, what do I have left? That's my numerator. Now remember, this is all over h. So I'm going to take out an h. And when those h's cancel, remember that h is supposed to approach 0. So in the middle here, this thing is pretty much non-existent. And what do we have left? This is that derivative. Now again, why am I showing you all these? Well, just so you have exposure to all three. We're probably going to use the first and the second one most often, but I just want you to have exposure to this. And you probably should put it on your yellow sheet, because there are going to be some cases where this is going to be easier to use. So that is your lesson today. Your homework is right here. So I will be checking this in on Tuesday when I see you next.